Okay, so today we are going to go through gas laws, so the ideal gas laws. So first, we'll review the formulas for Charles' law, Boyle's law, Avogadro's, the combined gas law, as well as ideal gas law. Second, we'll go through gas stoichiometry and then practice problems. So first is introduction, and this is Boyle's law. So Boyle's law falls in, Boyle's law falls into pressure, involves pressure and volume. So you'll see initial pressure and initial volume is equivalent to final pressure and final volume, or in this case, 1 and 2. We can use them. Charles' law involves volume and temperature, the relationship between volume and temperature, and it's inversely related. So it's V1 over T1. So V1 over T1 equals to V2 over T2. Then we have Avogadro's law, which is volume and amount, which is moles, which is symbolized with N. And you have your combined gas law. Combined gas law, which is P1 and times V1 over T1. So we're on combined gas laws. Again, it's you're combining Boyle's law with Charles' law, where P1 over V1 is over T2 times P1 times V1 over T1 equals to P2 times V2 over T2. Okay, moving on. So your ideal gas law is PV equals to nRT. For pressure, the unit that we always want it in is atmosphere, ATM. Volume is in liters, not milliliters. Moles. Temperature, the SI for it is Kelvin that we want. And the gas constant is R equals to 0.08206. Some students, your professor might be using R equals to 0.0821. Just depends on which one they want. You can use either. We'll be using this one in the problems that we're working through. Okay. So example problem that we're going to first do is CH3OH can be synthesized by the following reaction. So this is a balanced reaction that we've been given. So the question is, what volume of hydrogen gas in liters at 738 millimeters of mercury? This is our pressure. Our temperature is 355 Kelvin. To synthesize the given amount of CH3OH of 35.7 grams. So the first thing we would do when we're given this is they're asking us for volumes of hydrogen gas, right? But you see here that the mass that they've given us is for the product. What to do first? What do you guys think?
We have to find a mole.
Yeah.
The mole of CH3OH.
Versus, yeah, so you go from moles of CH3OH to your, yeah, to moles of H2.
And then we can compare the mole ratio.
Yeah, you can. Yes, you use your mole ratio, and you're going to calculate to moles of H2. So we're going to do this using stoichiometry. So actually, first, I just want to do this. So 738 millimeters of mercury How do you get it to atmosphere, ATM?
Divided by 760.
Yeah, 100 millimeters Hg. Okay, so 738 divided by 760, you get 0.971 ATM. Okay, so going from 35.7 grams CH3OH, its molar mass is 12.01 plus 1.01 times 3 plus 16 plus 1.01, another one. So 32.05 grams. 1 mole. So what's the mole to mole ratio?
The molar mass of the CH3OH, correct?
Yeah, it is.
Okay, thanks.
Mm-hmm. So the mole ratio is 1 to 2. And that is, so if you do, oh, oopsie, sorry, of H2. There you go. You guys do this, you guys should all be getting 2.22. 35.
2.23.
Would you not round it to 2.23?
Yeah, sorry. Yeah, 2.23 moles of H2. So now that we have moles of H2, we can plug it into which formula? Which gas law?
equal nRT.
Yeah, PV equals to nRT. If we
So
rearrange it,
V equal nRT over P.
yeah. Okay, so now over P, sorry. We can just plug everything in. 2.23 moles times 0.08206 liters times ATM moles times K. Temp is 355 Kelvin. All over your 0.971. So your volume should be, can you guys calculate it too? And let me know what you guys get.
Sorry to interrupt. What is written under the 35.7?
35 point, oh, I put product. Because CH3OH is our product, not our what we want. This is a reactant.
So it is 66.9.
Yeah. So I got 66.9 liters of H2 gas. Did you guys all get the same answer?
Yeah.
66.9? Yeah. Okay. So this would be how you'd approach using stoichiometry with this reaction. Okay. So next, we're going to go through all practice problems. So you guys, I'm going to give you guys time to do them. We have 8 of them. Okay. So heads up with the number. Do you guys need more time to copy this down, or can I move on?
1 more minute, please.
Okay. Okay, I'm going to move on. Again, you'll get a recording of this, so you can look back on it. So now it's your turn to try practice problems. Give you guys 5 minutes to do this problem. Let me know if you guys need more time. So I got 1.3 ATM, which most of you guys got. Some of you guys got 1.28, and that comes into play with sig figs again. So you'll note that the pressure here is 1.1, and that's 2 sig figs, whereas the other ones are 3. So you want 2 sig figs for your answer. Okay, Moving on to the next one. Okay. Again, 5 minutes if you guys need less time, or if you guys are all done finishing it up already, then we'll go over the answers sooner. Yes, okay, I'm going to share screen. I think you guys might have seen my Blender earlier. I actually shared my work already. But yeah, for everyone who got 1.15 milliliters or 0.0015 liters, then you guys got it right. Again, yeah, you're just using here was V1 over T1 equals to V2 over T2. Any questions on it? We'll move on to the next one.
I think we can use the unit is millimeter because the question doesn't say anything.
Yeah, so it doesn't specify. So that's why for me, I was just putting in liters. So you guys can put in milliliters or liters. It depends on what you ask for. This one didn't specify. That's why in the chat I put in convert to liters. Final answer in liters. Yeah.
Mhm.
For the most part, usually they might want it in liters just because that's your main unit when you're using gas laws. Okay. This one, 5 minutes, 7:30. Again, I would prefer your final unit for the volume to be in liters. So convert if you guys have it. So the first thing that I did was I converted all of the temperatures to Kelvin and the volume here, your V1 to liters. And I got this. So looking at this, you have really one option that uses volume and temperature. And that is V1 over T1 equals to V2 over T2. If we're looking here, we're trying to look for V2, right? So if we rearrange this, what you're plugging in is V1 times T2 all over T1.
You gotta flip them over, so.
Okay, yeah. So then once you plug this in, so initial volume is 0.0493 liters times T2, which is 360 Kelvin, all over 295 Kelvin. And you should get 0.493 times 360 divided by 295. And you get 0.06016, which goes to 0.0602 liters for your volume, which for the most part you guys got. If you didn't get it, if you didn't get it right, so does this make sense now? Did you guys all get the same
Yes,
answer
I think
now?
I just misplaced the equation.
Yeah, so when you're rearranging it to isolate the one that you want, right?
Yeah.
Okay, it's okay. We caught it now. Okay, so let's move on. Let's move on to the next problem. So problem 4, I'll give you guys 5 minutes again, so 7:35. Let me know if you guys finish early and we can go over.
Oh, actually, I have a quick question. So like when you get an answer like that on the prior
Yeah.
one, do you should you not convert it to or like can you
liters?
convert it to the scientific notation?
You can.
Okay.
Yeah.
Doesn't
So
matter?
yeah, it doesn't. Yeah, for 0.0602, it's still 3 significant figures.
Mm-hmm.
Whichever one you're comfortable with, you can put it into scientific as long as your sig figs are right.
Okay, thanks.
So 30 liters was the answer, 29.6 rounded up. So first, we P1, V1, T1. Once you're noting all these variables, you can figure out, it helps you figure out which equation you're using. So here we're using the combined gas law. So I didn't rearrange it just because I didn't want to mix up any variables just in case. So what I just did was I wrote it out and then I plugged it in. Then I divided it by P2 divided by T2. Then I got my V2 and I rounded it to have 2 sig figs due to your values for P1 and V1 and P2. Questions on anything? Okay, there you go. So what is the mass of a gas at pressure? Sorry, so there was a typo here. I want the moles. Yeah, I want the mass of the gas. The gas that we have is O2. So you guys can convert. I got 0.127 grams of O2. So first, I went through converting everything to the units that we need for PV equals to nRT. Because you notice that we're given the pressure, the volume, temperature, R is known. We want to find moles of O2, then use stoichiometry to get the mass. Measure analysis. So first, pressure, got 0.97368, volume, 0.10 liters, temp, 298. I rearranged PV equals nRT to N equals to PV over RT. Ah, got it. Try to not make that mistake, especially when you're when you're taking your exam. I still remember I did it once, I think when I was taking my 1A or 1B exam, and it changed my answer and I got a partial credit at least because the professor sees where you went wrong. So I plugged it all in, got 3.98 times 10 to the negative 3, brought it over, 32 grams of O2 in 1 mole, and you get 0.127. Questions? We're good to move on.
Someone's asking for ATM, why are we using 5 numbers instead of only 3 sig figs?
Oh, for that one, I just wanted to keep the numbers in case anything changed. Up to you if you want to keep 3 sig figs or not. Sometimes I do that if we're doing PV equals nRT. It just depends. Your value doesn't really change. Having more numbers is sometimes even better. Your sig figs just refer back into the question itself. Does that answer your question, Sabrina?
Yes, thank you.
Yeah, okay. Next problem. 5 minutes? More or less. Let's go over this one. There seems to be some numbers rounding off and everything. Okay, so this is what I did. So first thing that I did was convert everything to the units that I want. Kelvin, heat Kelvin, ATM. Everything else was in our ideal units. So then when you rearrange it and you plug it into N equals to PV over RT, I plugged it in. And I think here's why some of you guys are getting 70.7, 70.8, and 70.9, the amount of sig figs you keep. One thing you want to remember when doing these calculations that your professors may generally say is you don't do your sig figs until the end, typically. If you're going to continue using this, the mole that we find for n is not our final answer. So you don't necessarily have to do sig figs here. You might actually want to keep as many numbers as possible. In this case, I kept 4 sig figs. You can keep maybe 5 even to use. So notice that we have 827 milligrams. Converted to grams. You can do it straight across. I prefer to show it. You convert it to grams first, and then you divide it by the moles that we calculated. Once I did that, I got 70.9 grams per mole. Do any of you guys have questions on how I got my answer or why? Clear up anything along the way?
I think it makes sense.
Okay. Yeah, so some of you guys with the different values, it comes along with the sig fig. So if you did 0.117, your number came off different, probably.
Someone's asking why you don't use density.
Use a density.
Density equals more mass over more volume.
Oh, you don't need to, because it's just, so your molar mass, if you think about it, when you're taking it from the periodic table, it's X amount of grams per mole. So you don't have to put it that way. Technically, I did do the density equation. If you want to, I can set it up like this. Over 0.01167 moles. It's the same answer. Just make sure that you had converted 2 grams first. It's the same setup. I just put it in the multiplication format. Yeah, okay. Next problem. Problem 7, we have one more. We should be able to get to it. So this is a 2-part thing. Answer it. I'll give you guys 5 minutes again. I think you guys can do it in 5 minutes. So I saw some of you guys put 24.1 liters for CO, which is good. So first thing I did, convert them into the units I want. Then the next thing that I did that I found important was using this mass right here. You're going to use stoichiometry to get your moles of H2 and your moles of carbon monoxide. From there, you can just plug it into your rearranged form for PV equals to nRT for the volume of H2 and volume of carbon monoxide.
So you'll have to do 2 different equations with the given grams of the product.
The mole, yeah. So the moles of the product. So
the moles of the product. Okay.
Yeah. So
you'll plug in for N.
Mm-hmm.
Okay.
So you go from CH3OH to H2. It's a 2-to-1 ratio. You should get this as your moles for hydrogen. 1-to-1 ratio for carbon monoxide to CH3OH. And you should get this value. Approximately depends on your sig fig. I just kept this much. Then plug it into your rearranged ideal gas law formula and solve for V.
Okay.
And you should have 3 sig figs for your final answer. Okay. We move on to the last problem. You might go over maybe by 2 minutes, but it's okay. You guys want to solve this on your own. So give you guys 5 minutes, okay? So 803.
50 đi thì nó giữ cái điện là 10, ví dụ điện 15 phao 50 đi là nó giữ cái điện 15 phao. Nếu mà 15 phao 60 thì nó làm tròn 16 phao.
So I think for the most of you guys got 1.9. Volume, temperature, pressure was given. You're solving for moles. The interesting thing here is that you're given the volume of O2. So you're solving for O2, for the moles of O2 first. Then you use stoichiometry to get your mass of H2O. 0.0518.
I have a question.
Yeah.
Oh, it's moles. I accidentally divided
Yeah.
it by 32, but it's already in moles.
Mm-hmm. Yeah. Okay.
So never mind now. I get it.
Okay. Yeah. So then you just multiply it by the ratio, 2:1, then multiply it by the mass of H2O to get 1.9 grams of H2O is required. Any other questions, guys? This is the end.
I think I did it. I solved it flip-flop first. So I
Okay.
did H2O to O2. How do I know how to decipher that in
H-
the question? Yeah, I don't know. I just put
Okay.
the 0.058 of H2O, but it was actually O2. I just did it backwards.
Okay. Okay. So yeah, I get what you meant. So the question is asking how much is the mass of H2O. So I think you just got tricked by that beginning part and mixed it with the O2 that they gave you value.
Mhm.
Yeah, so just try and read it carefully and see. Sometimes like you skim it through, right? And then you might
Yeah.
miss it. And then if you come back and check just to see. Because if you think of it this way, if they wanted you to find only H2O, they wouldn't give you this equation. You wouldn't need it.
Okay.
Yeah. Because if they
Right.
gave you the volume of H2O, then you would just use the molar mass that you can find from the periodic table for your answer.
Okay, thank you.
Okay, that's the end.
Thank you.